Okay, here we are, 4.1, section 4.1, talking about logs. We're starting to talk about the beginning logs and introduction to logs. What is a log? Essentially, to begin with, we need to understand what a log is and kind of how it relates, how logs relate to uh, exponentials. So in general, this is something that I'll write in red. Hopefully I can write this in red. Log base b of x equals y is the same as, and this is interchangeable, it can go one way or the other, is b to the yth power equals x. Same statement, just goes back and forth. The base of the log is the base of the exponential statement, and x and y just simply switch places. So b to the yth power, you can kind of think of it as maybe going in a circle counterclockwise. B to the yth power equals x, b to the yth power equals x. So therefore, we're looking anytime we see a statement that is this in the blue box, it's kind of asking the question, b to what power is x? Because b to the yth power equals x, so we can kind of translate something. We can, if we're looking for this, the evaluation of this blue box, we can stick this maybe equal to a y, set that equal to y, and then kind of solve for y. So therefore, if this is equal to, if we go back down to this, well, let's see, let's go through the question, I guess. Log x is the exponent to which the base 10. Remember that if there's no base written here, we understand that it's a base of 10. It's a common base. The base of 10 is always going to be the base if there's nothing written here as a base. So log of x is the exponent to which the base 10, this base, must be raised to get x. Because base 10, 10 to the yth power, if we set this kind of equal to a y, 10 to the yth power equals x. Therefore, this question, log of x, is asking the question, what is that y that the base of 10 must be raised to get x? So let's maybe, I'm looking for this log. I'm going to look at set up this this table of data, I suppose. And if I say log x, let's see that it equals some y. So therefore, we can say that if I'm looking for this entry here in the blue, I'm looking for this value such that log base 10, unwritten 10, of x equals some y value. And we're going to plug in these x values. So the first one comes as log base 10 of x. X is 10 to the third. If x is 10 to the third power, then that equals some y. Okay, well, I can by inspection we could maybe do this, but let's set it up as going the long way. I'm going to change this log equation into an exponential equation by saying 10 to the yth power equals 10 to the third power. So here's my log statement, here's my exponential statement. Start with my 10 to the yth power equals here. 10 to the yth power equals that 10 to the third power. 10 to what power equals 10 to the third power? Well, because the bases are the same, then y has to be equal to 3. 10 to the third power equals 10 to the third power, therefore this has to be equal to 3. This question, same thing. 10 to what power equals 10 to the second power? Has to be 2. 10 to what power has to be equal to 10 to the first? 10 to what power has to be equal to 10 to the first? Has to be equal 1. So there's kind of a statement that we can kind of make. We can translate that equation into that log equation into an exponential equation and then solve for whatever y value we're looking for. So let's take a look at these. Remember that log base b of x equals y is translatable into and translated into b to the yth power equals x. This is something that's going to be really important. It's the basics of using logs and kind of playing around with logs. So if I go up here, question 2a says, translate this, 5 to the third power equals 125, into a log. The exponent into a log statement. Let's see, so I'm giving you this. Let's move back into this. The base of my exponent is the base of my log, so base of 5, and the 3 and the 125 switch places. 125 comes over here, and 3 goes right there. So log base 5 of 125 is 3 is the same thing as saying 5 to the third power equals 125, and that's what we started with. So in my mind, it's kind of easier to go from here over to here, but we have to go both ways. So question B then says, log base 5 of 25 equals 2. Let's translate that into an exponential equation. The base of the log is 5, so the base of the exponential statement is 5. 5 to the second power equals 25. Second power equals 25. And sure enough, is that a true statement? 5 squared equals 25? Yes, it's true. So there's kind of some basics about moving around with logs and exponential statements.